Good morning, good afternoon, and good evening to all our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. I'd like to start off our event today by thanking Teradata for sponsoring this event. Teradata is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Cisco, Tableau, Hortonworks, Looker, MapR, and Think Big, to name just a few. Past webinars are available on demand at datasciencecentral.com, and if you haven't had an opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to the data science community. So today's webinar is entitled 5 Things Your Organization Needs to Succeed in Data Science. And before we begin, I'd like to briefly review the format of today's webinar. Today, we'll have a 1-hour-long event. We have one panelist that I'll introduce in just a minute. There will be 10 or 15 minutes of QA following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the QA portion of today's event. I'm very pleased to introduce today's speaker, John Thuma of Teradata. John is a technology leader and evangelist recognized in data warehousing, business intelligence, and advanced analytics for his next-level strategies. With nearly 30 years of practical experience, John has developed and implemented real-world governance and international solution development programs across a variety of industries and disciplines. He's a regular contributor to many media outlets and a faculty member of the International Institute of Analytics. He's been working also with Microsoft, SAP, and TCS around data initiatives. Thanks for being with us today. We're looking forward to your presentation. So, what does it take to succeed in the world of data science and analytics? It takes the right culture, people, process, and governance, the ability to operational analytics, and special weapons and tactics. So in today's DCS webinar, John will discuss his strategy to conquer the 5 challenges to succeed in data science: culture, people, governance, getting operational, and special weapons and tactics. John, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Excellent. Thank you very much, and I'm really happy to be here. So the things we're going to talk about today are just some things that I've experienced over my 30 years in data and, what we used to call very large database, or, before this terminology of big data or data scientist or anything like that. So, this is a no hype zone. This is a real world zone of my personal experiences in developing not only the technology solutions and the math and the science and the statistics and the technology solutions that just, encompass just about everything from IMS to DB2 to, SQL Server to, of course, Teradata, Aster, and Hadoop. But it takes more than that. And it's really about, understanding your culture, your people, your governance, and, making sure you have the right mindset going into these kinds of projects. So before I start, I kind of want to give a preamble. You really got to look at yourself, and you got to really look at your organization. Let's have some fun here. Let's not get too critical or too harsh on ourselves. But are we the dinosaur? And I wake up in the morning and I think about this every day about myself. Am I doing something interesting today? Am I going to make a difference today? Or am I just going to take status quo and go forward? I try not to ever do that. I don't want to be that dinosaur looking up at the pretty rock falling in from the sky, looking at how beautiful it is, not knowing that it's going to crush me and destroy me and possibly make me extinct. I go to many different customers all the time, and they ask me, how do we compete with, the innovators out there? And you look around, things have changed. When I was a kid, we used to go to record stores and we had cassette tapes, and then we had DVDs and CDs, and now, there is no record store. It's gone. They closed shop. Now the vinyl records are coming back for another reason, but that niche will go away again. The idea is that there's new retailers, there are new ways of buying things and disruptors to technology and whatnot. Did you know that Amazon now delivers wood to your house or shingles to your house, and through Amazon Local that you can actually get a contractor to actually do the work for you? And so that's got a lot of different organizations terrified and concerned about what's going to happen. So one day you might just buy your insurance from a broker, an Amazon broker or something of that nature. So if you're not innovating, you're that dinosaur. So that's what the whole point of today is that, understand who you are. And so what is the fastest path? Everybody asks me what the fastest path to data science is, and there is no secret. There is no one thing that makes you a data scientist. I think, it takes, of course, math, statistics, and programming and being able to understand data, but it takes more than that. And that's what the point of this conversation is today. So let's jump right in. And let's have some fun today. Let's not get too serious. We will cover some very serious things, but let's have some fun. So culture. Culture is by far the most important thing is going to be a barrier to success in your organization, to being able to exploit data for value. Number one thing, what is your vision and your mission statement of your company? What does it say? What does it say about what it's going to do to innovate? What does it say about its knowledge of its customers, its knowledge of its competitors, and its ability to understand itself, and what are its most valuable assets? And of course, we all say people, but really the most valuable asset an organization has is data. And if your organization is not data central, right, not thinking about data centrality and understanding everything there is to know about it, for instance, I recently helped Teradata.com implement their website. And the first question I asked before we got started with anything, they wanted to build a new website and they wanted to put new, a new tagging construct in and whatnot, and they wanted to really to do something interesting. And the first thing I said, I go, wait a minute, what are your analytical objectives? And they looked at me like I was from a different planet. And, they might be right there, but I mean the point is they looked at me differently. They go, what do you mean? What are our analytical objectives? I go, what questions do you want to answer based on the data coming off this big, huge data website that's generating data? That's all this is now, is a data generator. What analytic questions do you want this website to help you answer? And they looked at me like, we didn't think about that. I go, well, we need to start thinking that way about everything we do. Our culture needs to change. The way we think about what we do and why we do it needs to be, what analytic questions are we going to answer as a result of this initiative? Why? Because we can't really measure the effectiveness of anything unless we have data about it and we have questions that we want to answer about it, and that we can set up that system to be much more adaptable to data analytics. So whenever you're going to implement a new ERP system or a new call center application or any kind of system in your company, as well as the processes for those systems, think of data. Think of the kinds of questions you want to ask. Think of the kinds of things you want to answer. Now, here's another advantage you're going to see. You're going to see that the way you structure and implement those systems is going to be designed to speed up data load and preparation as well. So that's just an accident of being able to get there. So, and then the flexibility, and what do we have to do to change our tagging mechanism for Teradata.com so that we can answer the future questions that we want to have? The idea is that we have to become a data central, analytics central culture. Other questions you want to ask. Do you have a data governance council? When you implement systems, what do you think about? What are driving your decisions to do things? Do you have published data guiding principles, about data? It used to be that CTOs and CIOs looked for every squeeze of every dollar out of every cost when it came to anything IT related or anything technically related. They thought that this is just a commodity that we've done everything we're going to be able to do. Well, that's not right. I mean, we really have to think about data as the central purpose of our information technology world. And what I mean by that is that do we govern it? Do we protect it? Do we secure it? Do we make sure we're using it properly? Do we track its lineage? Do we understand its consistency? And that takes a cultural shift, a cultural paradigm shift to make that happen. And that's not easy to do. Trust me, I've done it a few times and it takes work. So, when I think of things, and let's look at the discovery analytics, and let's look at the way things look. And if you look on the left side of this diagram here, all of us have lived in this environment. I've been in 25 to 30 years, I've been in, countless analytics shops or IT shops where I see this. And, on the left side, we have all these different disciplines. It's a candy store of different products, of different, capabilities, of different people working in stovepipes across the organization, right? Some people are really good with text analytics. Some people are really excellent with graph. Some people are excellent with statistical analysis and machine learning and predictive analytics. Some people are great with certain disciplines of that data too. Gross sales, revenue, profit, loss, risk, those kinds of things. The point is that there's a decentralization of the strategy. And there's stovepipes of brilliance in the organization, and there's no control over quality. There's no control over consistency. There's no control over cost. And that's the result of the environments on the left. Now, the environment on the right, the solution, is where we want to come up with, and this is another question that comes to me. John, if I'm going to start up a data science group or a data science team, what are things that I need to do or look for in developing this competency? And so, everybody has the stuff on the left. What we want to do is get to the panacea on the right, where we are looking to centralize tools, technology, and process, right? We want to centralize governance around these analytics. We also want to centralize access to data, right, as much as we can, because we want to get great at it, right? We want to have a clear, consistent, trustworthy data access environment and a clear, trustworthy, integrated, centralized analytics platform that supports a variety of genres of analytics, right? So what we want is, depending on the skill sets that you have in your organization, you can fill in these little orbs off to the right here that orbit around our integrated discovery solution. With Teradata, we liken this to our R packages that work with our systems. We actually have a MapReduce functionality that does SQL MapReduce. We have pathing and pattern analysis, text analytics and graph, and SQL analytics as well. You might liken this to BI infrastructure. What it is centralized. And then what I recommend is that you decentralize the people. Now, your leadership of your analytics environment will be centralized, but you want to decentralize the people that are actually doing the work. You want to get them out in front of the customer. You want to embed them in with the customer environment. So these are just some things. Being able to govern your data, being able to govern the tools that you use, being able to govern the people that you have, so that you can get excellent and develop a center of excellence around this is going to be that solution on the right-hand side of this slide. Now, the reality is, John, we're always going to have a little bit on the left. I agree. It's a panacea. It's a multi-generational plan to govern us to get us there. So with that said, let's continue forward. People. I think people are the number one thing your organization can hire and bring in and retain that are going to make analytics and big data and data science work for you. Being able to choose the right people is number one thing. Of course, everybody thinks of, math and statistics, and I got to go get these sets of PhDs and things like that. Yeah, I'm not going to disagree with you there. Those people are excellent, but they got to have more than that. They got to have more than math and statistics and understanding of naive Bayes and support vector machines and LDA and LAR and all these other deep learning type of analytics and machine learning topics. They got to have more. They got to have, and I'm going to start with the muscle. The muscle is my favorite kind of person, and I'm not saying these are individual people. I'm talking about the traits you want to get in your organization. The muscle is the person that never gives up. They no matter what technical problem, whatever business problem comes up, whatever, they will muscle through it. They have the chops to be creative. They're constantly looking for a solution on Google. They're always looking around a way of getting things done no matter what. They go through the barrier, they go under the barrier, they go over the wall, they go around it. They don't care. They just get things done, right? And this muscle is very important, and of course they have to be intelligent. The pioneer up in the upper left-hand corner is someone that is not afraid to look before they leap. They're looking for innovative ways to change the organization, and they're not afraid to talk about it. They're not afraid to go out in front of the business and go, what do I have to do to help you today? What is your top 5 problems, or what is your one glaring problem that if I could solve it would turn your business unit around or turn this company around and make a difference, right? You've got to have that investigative. Just being that person, that technology person locked in a basement is not going to do it, right? Because it takes a collection of people to make things happen. The cattle herder, so we're going up to the right, upper right-hand corner. The cattle herder is someone that can bring a lot of people together across many different disciplines, right? Because it does take a village here, to make analytics work for you and data science work for you. This cattle herder can talk to people in IT, can talk to data scientists, can talk to people in the business, can talk to people in quality assurance, can talk to people in leadership about analytics, analytic value, and they're much like the pioneer in that they're not afraid to go out and try to test barriers and things like that. Because it doesn't matter if I build the most sophisticated analytic in the world, if I can't get it integrated into the business and change people and process, which are the 2 hard things these days, changing people and their behaviors, their processes. If I can't do that, then my analytics are nothing. They're useless. They're going to be locked in a PowerPoint deck on some art on somebody else's wall, and they'll never go anywhere, right? The storyteller. This is absolutely critical. And the storyteller in the bottom right-hand corner, this is someone that can articulate very complex things simply. And I know that's a dichotomy to say, but I mean, this person can take all the stats, all the math, all the SVM, the support vector machines, because let's face it, there's a chasm between the language that data scientists and advanced analytics persons speak and a language that the business people speak, right? These people don't necessarily communicate the same way, right? When you go to a business person and you talk about parallel hyperplanes or Jacquard coefficients, you're going to lose them. And they're probably going to, if the business people go talk about their nomenclature, they're going to lose each other. So what's needed is someone that can bridge that chasm, bridge that gap between each other, so that they can communicate these advanced stories in a very easy way. And they just can't go and recite some statistics, because statistics people don't remember them. They will remember the story. They will remember why this is important, how this can impact my business, and how it's going to have a positive impact on the business. So now we just talked about the things that you want. Let's talk about the traits that you don't want. And let's have some fun with this, because this is going to hit home with a lot of you, and a lot of these traits may come off as something, hey, I exhibit some of these traits. We all exhibit these traits. There are times we ebb and flow that we exhibit these traits. But, some of these things we want to avoid for our data science team. The bully. The bully is just somebody that it's got to be my way. This is it, and I'm in charge, and I control this environment, and that's that. And that kind of inflexibility, that kind of rigor is good in certain circumstances, but it's not always good, because I have this guiding principle that I live my life by. No one is intelligent enough to be a dictator. No one knows all the answers, and a bully thinks they know all the answers. A bully likes to control everything. I work for this organization that it had to be this way, and that's that. And he came into rooms and he would just throw his weight around, and I'm the boss, and this and that. And what he did was he stifled creativity throughout the whole organization, right? The sloth. Watch out for these people, because we like the sloth. Everybody loves the sloth. Why? Because the sloth doesn't bother anyone. It doesn't make commitments, and therefore it doesn't let anyone down. This person just sits in the corner, is cool and calm and quiet, and doesn't really cause any trouble, never blows a commitment, never blows a deadline, because they never take on commitments or deadlines. The zealot. The zealot is someone that is it's got to be this way. It's got to be open source. It's got to be Hadoop. It's got to be this technology. It's got to be, it's got to be this way. They're religiously bound by some sort of technology framework that it must be this way, right? Now, I believe it takes a collection of technologies to be able to be successful. There are going to be times when I want to use open source. There are going to be times when I want to use Spark. There's going to be times when I want to use Aster and Teradata and other types of products, right, and Presto and whatnot. And that kind of flexibility enables us to be able to look at new approaches and new ways and the best way to solve a problem, because we should not be looking at a technology way to solve problems. We should be looking at what is the right technology to get the job done quickly and efficiently at the lowest cost possible, at the highest value possible. That is what I think, instead of the zealot, that you need. Now, the clown. The clown, we all have them, the jokester, the prankster, but they're a little bit more than that. They're really good storytellers. Like the sloth, you got to watch out for them, because everybody likes the sloth because they make no commitments and they let no one down. The clown does kind of the same thing, but they're more animated, more of the life of the party. They're always cracking jokes. They're always making fun of things. They'll take some light work, and they'll try some things, and they'll also make bold statements, right? They'll make very bold statements. Oh yes, we can do this, and then they'll disappear when it's time to get the work done. They're really the anti-muscle. So you look at the sloth and the clown. They're really they promote themselves very, very gregariously, but they don't get anything done. So these are the traits that I think you should avoid. Now, you can't go to HR with the clown and the sloth and the bully and the zealot, and you can't go to them with the cattle herder and things like that. So you've got to figure out how to build these kinds of traits and qualities into your job requirements. And you also have to look for these people. You have to look for these people that are already in your organization and find out why you can't bring these qualities and these characteristics out of them, because their creativity and their muscle and their desire to do things that have impact are what's going to really make a difference. So you got to look for the people that you already have, and you need to hire and bring in new people that have these traits and these qualities. All right, let's move on. So process and governance. I mean, I can't tell you enough how important process and governance is. I, again, come back to, some stories. When I first implemented my first governance program, it was about 15 years ago. And it was a data governance program I tried to do. And I came at it like a dictator. This is what we're going to do. These are your guiding principles. This is our charter. This is this, and this is how you're going to make, and no one paid any attention to me. So instead, and I failed miserably. And failure's okay. We learn from failure. But the point is that, and that's the unfortunate journey that I'm referring to here, it's really what you want to do is become more of an influencer, right? Because when you use the G word, it scares people to death. Governance can have a very scary kind of connotation associated with it. So really what you want to do is form a governance council. You want this governance council to have this ability to work together across, and you want to start with a small piece of a project. You don't want to bite off the entire sandwich. You want to chew just a little small piece at a time. Start with developing simple guiding principles. That there will be only one version of the truth of data. We will use data this way, right? Just simple little words to live by, almost like a mini data constitution, right? Appoint a sheriff and some deputies, right? Let these people be the people who look around and keep an eye on things, and make sure that they're diplomatic, and make sure, like a sheriff. The sheriff has to be elected, right? So they can't go out and just go rough ride over the community, because they have to get elected every time period. So the sheriff has to be diplomatic, but they still have to know when rules have to be followed, and they have to be diplomatic in how they get done. So appoint a decision-making authority, and this is where leadership comes into play. Whenever there's a problem that the sheriff brings up and the council can't make a decision, we have a process where the leadership actually makes the decision for you. So, and that's what I mean by getting the leadership team, the LT, behind it. And hang in there. It's going to be a bumpy ride, trust me. When you go in front of people and tell them that they have to follow this process for procurement or for this and that, there's going to be bumps along the road. But basically, make sure that this is something that you do as an influencer and not as a dictator. So, and this is a solution development process for very large data science and predictive analytics that I use. And I actually do this in 3 stages, and I call it the operational discovery framework. You can call it anything you want, but it's basically define, integrate, and measure. So you define what you're going to do, you define the goals, you define the people, the subject matter experts, you define the data sets that are needed. Of course, you define the use case and its value back to the business, and as well as what success means. You define what you're going to measure. right? So, and then the next stage is integration. This is where the real technical work is done. This is where, we actually build all the models, and we build, the predictive analytics, or we build the scores, or we build what I call the big analytics or big data KPIs. Don't forget what you've already learned when it comes to analytics and the next level of analytics for your future-looking analytics, forward-looking analytics, and things like that. So, and also, you got to look at something else. It's not just about the analytics that you build. It's about integrating and embedding the analytics into the business systems and people and process that are going to use them and leverage them. So you have to be always thinking about that. So you just don't build the analytic. You build the analytic to be embedded or to be used by people. And that depends on what the solution is. If I have a churn prediction score, and I have a total customer value score that I'm generating off a big data analytic or a data science analytic, how do I get that score into the customer touchpoint systems like a call center application so that these people can use it, right? And then what kind of processes do I need in place? If I have a high-value customer that's on the way to churn, then I'm going to have a different process for that customer than a very low-value customer that's on the risk to churn. So how do I build processes to be able to use and script out how people are going to actually behave based on the outputs of a big data analytic? Because if your big data analytics just locked in a file somewhere, or it's locked in a PowerPoint deck, people aren't going to use it. And we'll get to this a little bit later, but it's not about the visualization, right? We, as organizations, and I'll get to this, I'm getting ahead of myself here a little bit, but it's not about the beautiful Sankey chart or the beautiful Sigma chart or the beautiful Tableau report that comes out of it. That's important, but that's not the answer. That's not the real visual, and I'll show you one here in a little bit. Measurement of success is absolutely critical. What did we do is what we define what we do, we build what we do, and then we measure it for success. And by that, and let's take our churn example that I used. Well, our goal was to save 25% of our high-value customer churners. Well, if you're not measuring, if you're not keeping score with what you actually, and you're not embedding those into the processes that manage churn for customers' touch points, then there's no way you can measure it. And then there's no way you can actually reflect a true return on investment. And so by being able to measure, we're actually going to embolden us to gain new projects going forward, right? And we use that to always look back. Well, we didn't quite get we didn't get the business results that we expected, or why, right? We have to look at, did our analytics fail? Did our people fail? Did our processes fail? And we have to change and adapt, and we start the process over again. So really, this define, integrate, measure is really a cyclic. It's a cycle that you're constantly going through. All the while, you're worried about people, process, and technology. I'll tell you, the technology is the easy part these days. It's the people and the process that are hard part. You got to have governance, which we just talked about, and we're talking about now, and you got to have operational and organizational support. Without leadership and without the business involved in your analytics and being an intimate team player in there, it's not going to work out. All right. So, have you considered these topics in your big data planning? I mean, is data integration, is that really dead? I mean, you're hearing all this stuff, and if you go on LinkedIn and you're reading all this hype about how data integration is dead, and I disagree. Data integration is very much alive and well. If I've got, in my data lake, I've got 50 different types of data in it. How do I make all that data work together, right? How do I find a common ID? Do I do everything schema on read? Well, what if I've got trillions of instances of those? Schema on read isn't going to work. I'm going to need to integrate data and pull it together across many different channels of behaviors and so forth. And then I'm going to need to integrate my solutions into my back-end systems and into my business systems. So data integration is absolutely very much alive and well. Master data management is critical. You know, it isn't something that comes up all the time. You know, if I've got, 50 different data sets in my data lake, and they come from third parties, and they come from websites, and they come from maybe customer loyalty systems, and they come from, maybe CRM systems, or customer relationship management systems, and they all have their own unique identifiers for customer and product. How am I going to get all of those things to work together? Now, how am I going to do it without integration? I'm going to need integration. I'm going to need a master data management process, even for this more than ever. Data quality. Data quality is absolutely still critical, right? Data consistency is absolutely still critical. If my data is unreliable and it's in an inconsistent format, how do I use it across millions or trillions of instances of it? If every schema for every XML file I have is unique, how do I do any kind of reliable analytic against that? And data security and data privacy, still very, very, I wrote blogs about this years ago, when Hadoop was just taking off, about, are you nuts? Are you thinking about putting PCI, payment card information, in Hadoop? Are you thinking about putting PHI, or protected healthcare information, in Hadoop, and what that means? If you're not thinking about the privacy or the security of that data, just because it's landing in the lake, and you don't know who's building what and who's got access to what and what they're doing with that data, even if you de-identify it, right? One of the constructs of HIPAA and PHI is you can't make your data re-identifiable. Well, if I bring together and I mash together a lot of different data sets together, I run the risk of making that patient information identifiable again. And that's a HIPAA violation. So we have to be cognizant. Just because we can doesn't mean we should, right? And so another thing, should I do everything in the cloud? Everything's cloud. Everything's cloud first. All the big players are cloud first. And I'm like, well, maybe. It depends. Maybe we should be cloud maybe, or maybe we should be cloud agnostic. I mean, look at your cloud providers, right, and think, do they have an on-premise solution as well to work with the off-premise solution? And do I want to push out all my data to the cloud? And with all these things we just talked about, privacy, security, consistency, and quality, and master data management, can I afford to put all that data on someone else's turf? Or do I still want to have control over within my most protected and most valuable asset, my data? So that's why I'm very cloud maybe. I'm very much pro-cloud. Don't get me wrong. I think cloud is excellent. But it has to be thought through, and we just can't have blanket policies that said everything's got to be cloud in 5 years, because that's not real. That's not a rational kind of way of thinking about things. All right. So the logical analytic hub, and this is, if you remember the first couple of slides we looked at earlier, this is really breaking this down into more of the, what are the components, what are the things that we need, right? You're going to need a real-time component or a near real-time component. You're going to need look-backward analytics, and that's where the integrated data warehouse is. That's your BI reporting and your standard BI dashboards and reports that look backwards to the last ETL drop. You're going to need an analytics environment, which is that gray area in the middle. And this is where I do things like support vector machines and machine learning, and I do things like k-means, and I do this against massive amounts of data. I do behavioral type of analytics, and I have to be very cognizant of scale and of performance and of the ability to find the people that can support these environments. Have we thought about, let's say you go out and you build this amazing Spark or Hadoop solution, have you thought about what you're going to do if that becomes production? And let's say, and by production I mean it was once an idea, it was a science project, or it was something that we thought was valuable, and and somebody saw the outputs, and now they want it every second Thursday of the month. Well, you just got an SLA. You just got a service level agreement for that output. That means that I've got to productionize my Hadoop infrastructure. I've got to productionize my data infrastructure, my analytics infrastructure. Are we ready for that? And that means segregation of duties. That means I've got to have different people that not only build the software and build the solutions, support the software, support the solutions possibly, as well as operationalize it in the IT infrastructure. And then I've got different ways to move the software along from dev, test, prod, and so forth, right? So I got to think about that. And is my organization mature enough? And here's the number one thing: does my technology support that? What technology decisions did I make that could impact my ability to support this infrastructure? And can I find the people that can support it, right? And I don't know where you live, but I live in the Midwest and I live in the South. It isn't exactly the Silicon Valley, right? I don't have an abundance of high-tech people. So you got to be very cognizant of these things along your journey. Let's get operational. This is the next phase. And by operational, I mean let's get the systems embedded in the business. And we've all focused, laser focused. I mean, we've seen some beautiful visualizations and some gorgeous, we all see, what is the visualization of the month or the visualization of the decade? These things are great and they're important, don't get me wrong. They're excellent tools. But if you were to show this to someone working in a grocery store, they'd look at you like you were from Venus, right? If you were to show this to someone working in a call center, they wouldn't know what to do with it. This is a data science tool. This is an analyst tool, a business analyst tool. It's great for strategy and tactical business decisions. But when it comes to actually doing things with your customers, what does it take? What really matters? And this is what I mean by the real visualization. This is the real visualization. What you're looking at here is a call center worker, and this is a screen mock-up that I built. And we've actually done this with many of our customers for churn prediction and customer evaluation and things like that. And it's a mock-up. So basically what you're looking at here in the left here is a call center application for I believe this is for a telco company. And it's really, the real visualization is that there's 3 red words down below: retain this customer. So put this in the retained customer program. That's their next action. Why? And they're a churn risk of 80%. Their days to churn, we got about 90 days before they start to churn out. And then their customer value is very high. They're a very high value customer. I want to keep this customer. So this person in the call center would click the retained customer program and scripts would come up. This is the business process that they would follow. This customer would also get the best IVR systems, the IVR pass, so they don't have to sit in the queue forever. This person would also get, the offers and the deal forgiveness and the bill forgiveness and things like that. So not only have we, if you look here, this sums everything up. This is the embedded analytic. This is the embedded visualization. And this is the real visualization, right? Because this is where we're actually taking action upon our analytics. And without that action on our customer, we're not really doing anything, right? So this is, I think, one of the most important things that I talk about these days. This is the last mile of analytics, the last mile of this process. So to do that, what does it take to do that, right? So you've got your data sources on the left, and I don't care what your use case is. I don't care, it doesn't matter. It could be churn, it could be next best offer, it could be, some sort of machine failure. It could be a lot of different things, right? The idea is that you need these 4 pillars off to the right. You have your data to the left here in the gray box, your sources here, of course. You have your data zone on the left-hand side, which consists of a data platform, and this could be something like a Hadoop infrastructure. It could be a NAS. It could be a bunch of spinning disks. You need your analytics solutions, right? This could be likened to an Aster or an SPSS, or it could be Hadoop, or some sort of Hadoop solution. It could be Spark. It could be a lot of different things, right? And then up above is the integrated data warehouse. This is what we're traditionally seeing. Everybody's heard of Teradata, and what we do here is a SQL-only platform for developing key performance indicators and reports, and people rely on this infrastructure every single day. And you just can't go banging away on this and doing new things here. Its schema is protected. It's tightly under control. The analytics zone is really the area where we acquire data, we prepare data, we analyze, we do our analysis, and then we actually do information delivery and we embed analytics. And the reason I have these arrows going around is because, the little blue arrows here in the analytics zone, is because our analytics are never done. There are organic things that occur, there are inorganic things that occur that cause your analytics to fail or to not be as useful, right? So what I mean by that is if you look at there was a commercial that came on the Super Bowl, I think last year. It was a buzzard flying around. It's for a telco operator, and they're saying, is your telco operator eating your minutes? And that's an inorganic thing that happened to all the other organizations that compete with that company that changed their models. All their churn prediction models were going to break the next morning. And I remember looking at that commercial, going, oh man, I'm going to be going to work tomorrow, right? And not only are the competitors to that changing, but also the organization that ran that commercial, its models are going to change too. Because I don't know about you, but a lot of people watch the Super Bowl. Any kind of commercial that's going to be disruptive is going to be an inorganic change and an organic change to the point of view of the customer that's watching it and the point of view of the company that implemented it. All right. And then the integration zone. This area is often not thought of. And by that I mean, how do we get the answer, the results of our models and our scores from our big analytics and from our data science, how do we get those over to the application zone, which is the final pillar here, the application zone? These are the systems that people use to manage your customers, right, or manage your citizens, or manage your patients. How do we get what was done in the analytics zone over to the application zone? And we have to think about that. We just can't think just about the analytics in play. We have to think about how we're going to get, is it going to be an enterprise service bus? Do we have an API layer? Do I have to develop some sort of custom code, right? What kind of governance do I have over that? What do the data structures look like, and what to feed into those systems? At what frequency am I going to do that? So these are the things that you have to look out for in order to do that. And of course, on the right, all the way to the right, you have all the people, right? So really, these are the business people. This is the business leadership. This is the people that are working in the call centers. These are the people that are managing in the stores. They're at the point of sale. What are they doing when something comes across the point of sale? Or what are they doing when a caller calls into the call center and they're low value and they're at risk of churn? Do they try to keep that customer? Do we prioritize them into I must keep this customer, or do we help them leave and go to our competition? And yes, that is a very real and viable way of doing it. And of course, across the bottom here, you have all your IT and analytics and your operations and project management and your programmers and your data scientists and your quants and things like that. So you can see that this ecosystem sounds daunting. It really isn't. These are typical things you have to do for any kind of project that you're going to integrate and change your organization with. These are very typical things. And then finally, we're going to close off with the 5 things that your organization needs, what I call SWOT. And this is the commercial end of our discussion today. So I call them, instead of weapons, I used ways, special ways and tactics, so that we can kind of make that a little more PC here a little bit. But basically, fail fast, change fast, iterate fast. What I mean by that is failure in analytics is okay. It's all right to make mistakes. You're going to pull data in from different systems. You're going to prepare it incorrectly or improperly for the analytic. You're going to need to change fast. Is it one analytic model over another? What do I have to do to prepare that data for that analytic model, right? And the ability to, if I've got a huge code surface area, and what I mean by that is the code surface area, how many lines of code does it take for you to change your analytics? And you will change your analytics. You will either do them because you didn't do them properly, you didn't prepare your data properly, or you didn't get the right data into the system, or you didn't do your modeling properly. How many lines of code do I have to change to make anything change for that? Especially given the inorganic and organic things that occur to models that cause them not to work as effectively anymore. If I have to react to a change in something that happened yesterday in my models, is it going to take 6 months to get it done? Because by then, it's too late. Your opportunity's gone, right? What is my runway? What is my time? How much time do I have to get anything done to actually operationalize an analytic before it's too late? And if I've got a highly complex system that's, it's got hundreds of thousands, if not millions of lines of code, and I'm talking like Java or C++ or Python or whatever, if it's got all this really complex code, how long does it take me to change my direction of my telemetry? What I call that is the code surface area. We have to look at is how many lines of code I have versus do I have fewer lines of code and can I get things done quickly, right? And we want to look, and we're going to show you that today. Leverage the skills you already have. Most organizations already have SQL skills. They already have an abundance of ANSI SQL skills. And I understand that there are limitations into what ANSI SQL can do. And I understand that. But there's a new form of technology that we've introduced here called Aster that I want to talk to you about. And it's really called SQL MapReduce and SQL Graph. And what we've done is we've taken all that code and we've obfuscated it into an API that looks like SQL but does all that complex stuff much easier. So does your environment support multi-genre analytics? Meaning, can I do text analytics? Can I do path and pattern analysis? Can I do all these different, graph analytics? Can I do machine learning? Can I do R? Can I do SAS? At scale and at performance, right? All the while, I'm concerned about privacy, security, reliability. All these things are built into my environment. Well, let's take a look at the way things have been done in the past. You look at this big, and this is really the total cost of an analytic, and it's kind of a fictitious example here. But you look at the two big areas. You got data load and preparation in the red triangle, the big triangle, and you've got analytic development in the green triangle up in the upper right-hand corner. You'll see that most of the time is spent, about 80% of it is spent in data load and preparation. Well, nobody ever slaps anybody on the back and gives them a big hug because they did all this great work in data load and prep. Don't get me wrong, it's cool and it's interesting, but the idea is that it's highly expensive and it's not very valuable. Data load and preparation has really no value to an organization. It has huge value to an analytic, right? I will give you that. So what happens as a result of that is that I spend fewer minutes and hours in my analytic development. And so what I want to do ultimately is get to a point where I shrink down my red triangle, my data load and prep time. I want to use things like high-speed connectors like Query Grid. I want to use things like high-speed network connections. I want to use tools that allow me to do data load and prep at scale across an MPP infrastructure and a massively parallel infrastructure very, very quickly. And I don't want to have to write hundreds of thousands of lines of code to do that. The minute I avoid any of those things, I can't change fast. I can't speed up my process. So as a result, I can still get my analytic development done, but it also leaves me more time to do analytic refinement. And maybe I want to test different models. Maybe I want to test different data load and preparation styles. Maybe I want to do something different, or maybe I want to run it through a QA or a confusion matrix or something of that nature where I can actually look at what's going to happen when I implement my model, right? So if we overlay what we did in the past, and this is kind of a complex thing here, bear with me, we're done with our old model right here up in about halfway through with our new way as opposed to our old way, which is up in the upper right-hand corner. Thus, we're saving about 50% of the cost and time to doing an analytic with our environment. Now, why is this important? Because, one, if I have to change my analytic data load prep analytics and information delivery, I want more time to do it, and I want less complexity to do it. But also, I want more time to operationalize my analytic, meaning I want more time to work with my business people. I want more time to do something about changing my business. For instance, if I have a churn model and I develop that churn model, I'm able to integrate it into my business, but it takes me 90 days to do it, and people churn out in 45 days, then my analytic is not successful. So being able to shrink down that time and costs is really important. And this is what I call the analytic development gap and the data load and prep gap. These white lines are hard dollars. They're costs. They're cost takeouts. So how do we get there? And I really believe that Aster, Teradata Aster, and I've been working with this technology for 3 years, does all these things that we need. One, it brings together multiple genres of analytics, right? I can do R. I can do machine learning. I can do text. I can do graph. I can do path and pattern analysis. I can write my own analytics if I want to, right, and deploy it down in the Aster system. Aster can scale to petabytes if I need to. So no longer do I need to sample. No longer do I need to look at just a small piece of my data infrastructure. And I have the Teradata Query Grid, which allows me to talk to and integrate with other data forms, right? I can talk to my data warehouse, my integrated data warehouse. And that integrated data warehouse can be a Teradata systems, but it can also be any JDBC or ODBC compliant data source. It can be Oracle. It can be SQL Server. It can be, any JDBC compliant system. I can also ingest rapidly XML and JSON and HL7 data rapidly into Aster and be able to make it useful. The other thing I can do is I have a SQL connector to Hadoop that allows me to actually run real ANSI SQL queries against those data structures and manipulate them and use them in that environment. The idea is that Aster provides all this functionality in one core place. And that's what we call multi-genre analytics at scale. And that's important because I don't want to sample, especially with R. And we'll get into R and why Aster R is so unique. So let's go over the SQL MR. SQL MapReduce is something I talked about. Remember I talked about how ANSI SQL is a skill you already have? Well, imagine if I could take that skill set and they're also curious about data science or they know about predictive analytics. They want to use this kind of metaphor to get things done. This is how all of our functions work in Aster. You basically have a create table as statement, which is the red portion. So this completes NB model is the name of the table. Select field names from my data source from naive Bayes text. Naive Bayes text is a SQL MR statement that actually generates a model, a predictive model, using some training data set, right? Instead of select star from table name, select star from view, or select star from another SQL call, I'm actually calling one of the 120 plus analytic functions that's available to us in Aster. So all of our functions work this way, and I'm going to show you a list of our functions here in a second. On complaints, the blue side is the data source that I'm acting upon, right? This is a table in Aster. This could be a view into Hadoop. This could be a view into Teradata. It can be a view into Oracle. It could be another SQL call, right? So that's my data source that I'm going to act on with naive Bayes text. And then these brown fields, text column, categories, are predicates that tell naive Bayes what to do and how to behave. That's it. Now here's the beauty. That's a very easy infrastructure to learn, right? And we have 120 of these functions across all these disciplines. And I'm going to get to, these are the disciplines that we have available. It's kind of hard to read, I apologize, but there's statistical analysis, there's clustering, there's the ability to do text analytics, association analysis, collaborative filter, and market basket analytics at scale. We have a graph engine inside of our system, as well as other machine learning and decision trees and naive Bayes and all these different other analytics for being able to function on. They all work the same way as that select statement that you saw in the previous slide. So if I wanted to do a select star from C filter, it would be select star from, if I wanted to implement a C filter, a collaborative filter, it'd be select star from C filter. If I want to do a k-means, it would be a select star from k-means. And then I give it its predicates and tell it what to do. All right. So let's take a case in point. Let me give you an idea of evidence of what I've done. And I'm an actual hands-on practitioner. I actually do this for a living. And I want to show you what I've done. I landed here in San Diego with a customer, a big pharmaceutical customer, and I was in a meeting at 10:30. 10:45, I left the meeting. They basically said, by the end of the day, which is 5 o'clock, I want you to pull over 5 terabytes of data across Humatica data source. It's about 15 different objects, and it was about 5 terabytes, and then I want you to pull over some other data from IMS, which is a data accumulator for the pharmaceutical business. And I want you to pull all that together, and I want you to run a collaborative filter, basically what patients are taking what drugs. So if patient X took drug X and Y together, across 16 million patients, basically. And not only did I get the analytic done, I was able to do the affinity analytics. I was able to do all the data load and data preparation, and then I actually had time to study one of their drugs. So I had the PowerPoint deck ready to go, but I said, let's take this a little bit further. So I looked at one of their drugs, and it was like a rheumatoid arthritis drug for treating that disease. And what this drug did was that there was a lot of affinity with antibiotics. And I go, wow, that's kind of cool. Why is that? And I focused in, I did some research, and I found, and this is what the data told me, right, that this drug was prescribed very frequently by doctors, and they prescribed antibiotics with it. And I studied the drug in question. I'm going to leave the drug name out because it'll give away the company. But the point is that with these drugs, what this drug does is it stops the immune system from attacking the soft tissues in the joints of the body. So what's going on is that the immune system is actually eating away at the ligaments and things like that are and causing the rheumatoid arthritis to happen. So they prescribe these antibiotics because these drugs dampen or slow down the immune system. So to keep people from catching bacterial infections, when they give this drug out, when they prescribe this drug, they prescribe a lot of antibiotics as well. So I put all that together, walked into the customer same day by 4:30, and laid it down on the table, showed them what was going on. They're now an Aster customer. That's what we mean by fail fast, change fast, absorb data fast, low code surface area, small code surface area, reduce complexity at scale, and to be able to get things done. And I will say this, every environment I've been in, and every situation, every bake-off I've been in, I'm about 10x faster with more defined answers, better visualizations, and I can actually back my solution. So, and it's very simple to write and actually deploy this solution. Okay, so business intelligence tools can be used with Aster, so it doesn't matter. You can see here I've got a Tableau infrastructure, could be MicroStrategy, could be Spotfire, could be, pick your tool, could be SAP. We can actually call Teradata specific, Aster specific functions directly from there and visualize it. So it doesn't matter. Any of your favorite tools, your ETL tools, things like that will work with Aster. A big push coming out here very soon, and I'm almost done, is our R functionality, and that we actually, one of the common limitations of R is that it doesn't scale very well. And there's a lot of people coming out with school, and they're very proficient with R. They learned how to do it with open source tools, which is great. We actually have a plugin that works with RStudio, and we actually have a solution that allows you to scale R at very large data sets, and what's more importantly, against partition data sets. So these two things coupled together really take away the limitations of what you can do with R. And this is a very big deal coming out here fairly soon with Aster. And so when I talk about special ways and tactics, I'm really talking about the entire Teradata unified data architecture. I'm talking about the Aster platform. I'm talking about being able to leverage, leverage your data faster, better, and more inexpensively in order to get things done, in time to be operationalized. And so with that said, we'll enter the QA portion of our discussion. Thank you very much.
Yeah, hey, thank you so much for that excellent presentation. You covered an awful lot of material, and it was really, really informative and good. Unfortunately, we've run right down to the hour, so we're going to have to skip our QA session. But I want the audience to know that we thank them for their participation. We have a lot of questions that have come in, and for those that are not answered, we'll be passing those directly on to John and the Teradata team so they can follow up with you after today's webinar. I have just a few quick announcements before we wrap up for today. Please mark your calendars for September 29th and our next Data Science Central webinar, which is 100 Years of Data Visualization. It's time to stop making the same mistakes, and that's going to be sponsored by Tableau. Also, today's taping will be available for on-demand viewing later today and can be found on the home page of Data Science Central in the Webinar tab at the top of the page. Well, that brings today's presentation to a close. I'd like to thank our audience for their attendance and their thoughtful questions. And a special thanks again to Teradata for their sponsorship and our speaker today, John Thuma. Wow, that was terrific, John. My name is Bill Voorhees, and I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on September 29th. Have a great day.